in order for those to be like terms. I already know from the easy one that there's a 5 left over at the end, right? So I'm going to go ahead and try to break that up into 5 times something. Because then there'll be a 5 left in that one also. Then they'll be like terms, right? Maybe. Or if you guys don't think about that, you just start dividing by 135, start dividing it by 2, 3, 4, or be smart about it, divide it by 8, because that's a good cube root number, or divide it by 27, and bam, you'll be there. Right? Yeah.
So the 3.
The cube root?
Yeah, the cube root, that signifies to you, you need to find an answer that's cubable, like 8.
That comes from something cubed, exactly.
You have to for your solution.
Exactly. So it's a really good idea, and I'm hoping that from the cubes factoring we've done before, you know some of these numbers. Like we know 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is, right? So you should have those numbers there so you know what to look for, right? So sure enough, this guy now is 2 cube root of 27 times cube root of 5. Cool. Now I just keep simplifying. What is the cube root of 8?
2, 8,
And what is the cube root of 27?
3.
So I did the cube root of 8, it's there.
Yeah.
Cube root of 27 is there, right? So that 4 is still there. That is 2.
Yeah.
That's still there. 2 is still there. That is 3. That's still there. That's the huge thing about math is I'm just taking one part of it and simplifying, and everything else stays the same. We do that every time, right? So here this is
8
8 cube root of 5
minus
minus
6.
6 cube root of 5, which is
2.
2 cube root of 5. Now some of you might be able to skip a few steps that I've done. I'm trying to show all the steps. Well, you could just about go from here to here even possibly. But show me something. Show me somewhere. Or do every single damn step. It's going to keep you in line until you get comfortable with these, right? All right, you guys try these two. You guys try these. Oh, which one's John? I don't know.
جدا 5
لا 5
9 في 7 9 في 7
7 في 4
11 جدا 7 لا جدا
Just make sure real quick, you guys can tell that's a 5, not a 5th root. Right?
Right.
Yes.
I'll try to make it clear. In the book and on the test, it'll be easy because that's computer stuff. But in my writing, I try to be very careful about that. It's not very far from this being a 5, this, or a 5th root this. It's not a 5th root. Yeah, sure. I've been good. Pray to the math gods. no matter how much I lecture on this, I'm always gonna get about at least 5 people that tell me the answer to this is this.
No.
Do you see where that came from?
No.
You don't see where it came from?
They subtract.
Yeah, they have 5 minus 2 and 63 minus 28, right? And they go,
11,
no good, right? You can't just do that, right? It's sort of like telling me that 4 sevenths minus 1 fourth is 3/3, is 1, that's neat. Same exact mistake, really. They're not like terms, you can't do that. So here, the first thing, of course, how can you break up 63?
9/7.
I like it, 9 and 7, because 9 is square rootable,
Yeah.
just to make up an adjective. And then 28,
4 and 7.
4 times 7. Square root of 9 is
3.
times 5, 15. Now I'm going to start skipping a few steps. Square root of 4 is times 2 is 4, good. So square root of 4 is 2 times 2 is 4. 15 of these minus 4 of these is 11 of these. Cool. Seriously, this is like taking a big step back in terms of complexity. I'm hoping that you guys see this isn't really that horribly evil. And the cube roots, you might think they're uglier, but they're easier. There's only a few numbers that could possibly work here, right? 27 might work, 8 might work, 125 might work, right? So this one's obviously going to have to be
27 and 2.
27 times 2, yeah, so this is 3, cube root of 27,
Yeah.
cube root of 2. And then this,
125.
if you're not sure, you just divide it by 2,
Yeah.
125.
and you end up with 125, and that is cube rootable. So cube root of 27 is
3.
3. You still have cube root of 2. And the cube root of 125 is 5. You still have the cube root of 2 there. Because I can't do that, right? I can't do the cube root of 2, so it just stays there.
Minus
So now I have 9 of these, minus 35 of these, makes negative 20,
5. 26, sorry.
26.
26.
Yeah.
Minus
Yeah.
26.
Yep,
Yeah.
negative 26. Cool. Or understood? Yeah.
That's a piece of more.
Now, if you're nice to yourself, you will write, that 3 is still there. You've broken it up. That 7 is still there. You've broken this up. So you don't lose anybody on the way. I always get people that lose these numbers. They're so focused on breaking it up, that guy kind of drifts away at some point. And that's not the worst mistake to make, but it's still a mistake. Let's see. Alright, so for the last few minutes here, I'm going to let us out of here early, by the way. Let's go back and kind of firm up each section now that I've lectured through all the ideas I wanted to in the order I wanted to. Let's look at some of these sections directly. Go back to 7.3, for example. So in 7.3, they'll give you a problem like this, and they'll say, simplify that. I like this problem because it might be a multi-stepper depending on how you break it up.
4 by 3.
Okay, so you could do 4 and 20, right? But then what's it's not wrong with it, but you're just not done. Square root of 4 is 2. Well, what can you do with 20?
4,
5
5.
to the square. Square root of 4 is 2 times 2 is 4. So you could have broken 80 up as 16 times 5, but that's not the most readily available factorization of 80. So this is really akin to like akin. I don't use that word. Let's say what? Just say something down. 70 over. Sure, why not? 70 over 10. And for some reason you say, all right, 2 goes into both of those. But then you can go further, of course, right?
Yeah.
I mean, that's a terrible example, but you got it for us. But that's really what happened. You did what you could see, and then you say, oh crap, this goes further. Just like there, oh, it goes further. Right? Yeah.
The first one, how do you have 4 fifths? 2 square root of 4 5.
Well, what's square root of 4?
2.
So here's the 2. Square root of 4 is 2.
4.
Cool. So that's me skipping a step, so I gotta be careful. So then you get 4 of these. Cool. Now here's where it gets more interesting. Let me see what you guys think about this. This is the last thing we'll talk about today. This will finish out 7-3. And you can do 7-4 also. We've done 7-4 now too. This is the part, let me see. We are cool with this. Square root of 50 is not going to become a whole number. Because you can't do square root of 50. So I expect there to be a leftover ugliness there, right? That should make sense. Sort of like 18 divided by 9 is a whole number because I can kill the whole 9, but 18 divided by 10 will not be a whole number. Same kind of way. So square root of 50, of course, you've done that already.
25 too.
So that's that. So what do you think the square root of x squared is? Yeah, so we'll say it's x. Let's pretend like, we got to be a little careful because x could be negative. Let me see if I want to talk about this right now. X is a variable. I don't know what it is, but it could be negative. What do we know about a square root? What's the answer? Can
It's
the
positive.
answer for square root ever be negative? No. It's got to be positive, right? So to really cover my ass, I'd have to say this.
Unless you have a negative outside the square root.
Because what could x be, for example? If x is negative 3, what's negative 3 squared?
9.
9. What's the square root of 9?
3.
So was the square root of this square, was it negative 3? Was the answer negative 3?
No.
No, it was the absolute value of negative 3. So that, I could throw those absolute values in there to cover my ass. Because I know the answer's got to be positive, but what could x be? Negative. It could be positive, but just to cover my ass, I'm going to say the absolute value. Most of the problems we're going to do in this chapter, we don't have to worry about that because they'll say something like, assume all variables are positive. So we don't have to worry about these absolute values. They're not really that big of an issue anyway, right? So let's focus on that. Let me do the next step up. What do you think the cube root of x cubed is?
X.
Beautiful. Because a cube root can come out negative. We've seen that already. The cube root of negative 8 was negative 2. Right? So a cube root can come out positive or negative. A square root must come out positive. Square roots are always a lot more uptight, right, than cube roots or any odd root for that matter. Square roots can't handle negatives inside and they can't be negative at the end. Cube roots are like, what the hell's your problem? Put negatives in me and negative at the end, who cares? Right? Now here's where it gets interesting. So I could do, for example, figure crazy and say, what's the 16th root of x 16?
That's X.
X. And really absolute value, but that's not a big deal. As long as you realize those cancel each other, don't they? Now what happens here? What happens with the square root of x cubed?
We have to put this absolute x, the last one.
Yeah, you do,
Absolute?
but most of the time you're not going to have to worry about it.
No, this is brackets or absolute?
Absolute.
Absolute.
We don't
Because the
know
answer's
what,
got to be positive.
we don't know
right?
what X is.
3 over 2.
True, but
There's 3 X's in there.
good.